students, let us look at the problem 8. The mass of the sun is 2 into 10 to the power 30 kg. That of the earth is 6 into 10 to the power 24 kg. And the distance between them is 1.5 into 10 to the power 8 kilometer. So first of all, change this into meter. 1.5 into 10 to the power 8 into 10 to the power 3. So it becomes 1.5 into 10 to the power 11 meter. Now what is the gravitational force produced between them? Gravitational force produced between them, and G, gravitational constant, is given 6.67 into 10 to the power minus 11 Newton meter square per kg square. So we have to find the gravitational force. So first of all, what is gravitational force? So simply suppose this is body first and this is second, and according to our question, our first body is sun. Suppose this is sun, and next body is earth. This is earth. Our force exists is F. Suppose here mass is m1, here mass is m2, and force is F, and here distance is d. So we have to find the gravitational force, and we all know that gravitational force states that every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. So according to this statement, this force is directly proportional to product of their masses m1 and m2, and inversely proportional to square of their distance. So when we combine this both equation, then we get F directly proportional to m1 m2 by d square. When we remove this proportionality sign, then we have to add here one constant, that is capital G, gravitational constant, and its value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Here m1 m2, here d square. So this is the required gravitational force. Just by using this formula, we will be able to solve this problem. So let us look at the problem. So we have to find the gravitational force, that is F, and F equal to G m1 m2 by d square. So the value of the G is 6.67 into 10 to the power minus 11, and m1 and mass m1 is given 2 into 10 to the power 30, and m2 is given 6 into 10 to the power 24 by distance is given 1.5 into 10 to the power 11 d square whole square. So first of all, arrange all the numbers 6.67 into 2 into 6 and arrange this 10 power in one place, minus 11, 10 to the power 30, and 10 to the power 24. And here 1.5 whole square means 1.5 into 1.5. Here also we have 10 to the power 11, so it means 10 to the power 11 into 10 to the power 11. So multiply this term 6.67 into 2 into 6, then we get 80.04 into, here base is same, so it become minus 11 plus 30 plus 24. Here 1.5 into 1.5, it become 2.25 into 10 to the power, here base is same, so power should be added. Next, first of all divide this term, this 80.04 divide 2.25, then we get 35.577 into 10 to the power. Just solve it. This plus 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 54 minus 11 43 and here 11 22, so it become minus 22. 35.57 into 10 to the power, here plus minus minus 43 minus 22, it become 21. But we can write here 3.557 into 10 to the power 1 into 10 to the power 21. When we change into this scientific, when this decimal replaces in left side, so power should be positive. When this should be moved right side, then it should be negative. So again we have here same base, so 21 plus 1 22. So this is the required value of force, and we know that the unit of force is Newton. So this is the required value of F, that is gravitational force produced between them, that is F equal to, therefore F equal to 3.557 into 10 to the power 22 Newton. So let us look at the problem 9. The mass of the Jupiter is 1.9 into 10 to the power 27 kg and the radius is 7.1 into 10 to the power 4 kilometer. So first of all change into meter. So it become 7.1 into 10 to the power 7 meter. Calculate the acceleration due to gravity. So we have to find the value of g. What will be the weight of the person? It is second case. What will be the weight of the person of mass 85 kg on that planet? So this is our case second. Case second. So in first case we have r, m, and we have to find the value of g. So we have formula g equal to, in the first case g equal to gm by r square. So we know that the value of this capital G is fixed, that is 6.67 into 10 to the power minus 11 Newton meter square per kg square. So 6.67 into 10 to the power minus 11 into mass is 1.9 into 10 to the power 27 divide here r square, radius is 7.1 into 10 to the power 7 whole square. So solve it. First of all arrange. So first of all arrange it. 6.67 into 1.9 and 10 to the power minus 11 into 10 to the power 27. Here 7.1 whole square means 7.1 into 7.1, and here 10 to the power 7 square means 10 to the power 7 into 10 to the power 7. So just multiply this term 6.67 into 1.9. So required value is 12.673, and here base is same, so power should be added, and here 7.1 into 7.1, so required value is 50.41, and here also base is same, so become 7 plus 7. So first of all divide this term, 12.673 divide 50.41, so the required value is 2.513 into 10 to the power minus 1. Again here we have 27 plus minus 27 minus 27 minus 11, 10 to the power, it become 7 minus 1 6, 1 16, so it become 16, and this 10 to the power 7 plus 7 14, so it should be subtracted 7 7 14, so it become 2.513 into 10 to the power minus 1, and this here 16 minus 14, 10 to the power 2, so plus 2. Here 2.513 into 10 to the power plus minus minus, so it become 1. So when we multiply this term 2.513 into 10, so it become 25.13. so this is the required value of g. So we all know that the value of g is meter per square second. This is the required value of g, but we have second case also. Mass of the person is 85 and we have to find the weight, so this is case second. So we know that weight equal to mg, so mass is given 85 kg, 85, and the value of g is 25.13. so when we multiply 85 into 25.13, so the required value is 213.2136.05. This is required weight. So this is the required weight of a person of mass 85 kg on that planet.